Bismillahirrahmanirrahim. Assalamualaikum and very good day to you all. In this video, going to learn about chapter 11:10 Design Assessment for Selected Roller Contact Bearings from the book Shilling Engineering Mechanical Engineering Design. All the pictures here is taken from the book itself and also from the Google Images. Okay, continue to the chapter. Um, okay, machine element are treated singly. Okay, the textbook you can read all the explanation in this. What mean by this explanation? Because if you study other subject, other topic, uh, let's say the shaft. Okay, you design the shaft. You treated the shaft as a shaft itself. Okay, and also the gear you stated the gear as the gear itself. You have the calculation for the gear, you have the calculation for the gear, for the screw, for the bolt, for the spring. You have all the calculation individually. Okay, however for the bearing, many many parameters you will have to consider, like the lubrication, like the what effect bearing with other shaft bearing with other bearing with shaft, and all the elements, many elements involved with bearing. So um, in this case, uh, there is a design assessment. This is what we are talking in this video. Design assessment on the bearing itself. Okay, you can read all this text. Okay, the thing about bearing is that in designing the bearing, you may have to do it many times. Okay, it is called the iterations. At this point of necessary that the iterative nature of designing says a speed reducer, the power speed reduction are stipulated. The case set can be rough. The size, geometric location, estimate the shaft forces and moment identified. Bearing that is selected, seals identified. Okay, the bulk is beginning to make itself evident. The housing and lubricant scheme, as well as cooling consideration, become clearer. Shaft overhang coupling combination appear. It is time to iterate to now address the each element again. Okay, this is what mean by iteration, meaning that all the parts of the components related to each other. Okay, especially bearing, because bearing you come from the company. Okay, you don't design the bearing is designed by the company, bearing company itself. Then you have to suit the bearing with the need or your need. Let's say you have the shaft like this size. Okay, and then you are going to put the bearing. You have to choose the bearing, the C10 for the bearing, the C10, the catalog rating for the bearing, and the dimension of the bearing is suitable for you. In the end, many you have to take the consideration. If you design, calculate, you calculate, you're not satisfied, you do calculation again and again until you are satisfied. Okay, and then you in the end you select the better parts and tools for your design. Okay, this is a design assessment for the bearing. Out, an outline of design assessment of roller contact bearing includes a minimum. At a minimum, design bearing reliability for the load imposed of and like expected. Shouldering on shaft and housing satisfactory. General finish, diameter and tolerance compatible. Housing finish, diameter and tolerance compatible. Lubricant type according to manufacturer's accommodation. Lubricant path, volume, supply, and keep operating temperature satisfactory. Okay, lubricant we will explain much further in the next topic on general bearing. Okay. However, it also mentioned about lubricant here, but explain more in the next topic. Okay, and then the preloads is required. If you remember the topic about the screw, we talk a lot about preload. Okay, since we are focusing on rolling contact bearing, we can address bearing and reliability quantitatively, as well as soldering. Other quantitative treatment have to wait until the material for shaft and housing surface quality diameters are known. Okay, so this is all the design assessment. You have to consider more many things. Okay, okay. This is the bearing reliability. The question, the mind can be solved for reliability. Are the instead of C10 R equal to this equation, and 11 can be solved for RD, reliability desired, that what we want. Okay, remember the term D here is stand for desire. That what we want. Let's say I want the bearing to support the load of 1000 Newton. You want the bearing to support 2000 Newton. This is what you desired. Okay. And then you want the bearing to life to extend for 1 year. 1 year, you times 24 hours times 365 days, you get the value. This is the value for bearing, and then after that 1 year, the life value, desired life, and then you have to do the maintenance for the bearing. Okay. For example, 11.9, example 11.3. Okay, minimum load rating 99% reliability XD equals to this is dimensionless value XD. Life rating is 540 and system is 696 pound equivalent to 39.8 kilonewton. From table 11.2, minimum to 0 to 40 millimeter deep groove for bearing satisfy the argument. If the bore application had to be 70 millimeter or larger, okay, what is the resulting reliability? So meaning that this case, for example, given that uh, it already have the design, then you have to modify the design. You have to the shaft will become bigger. Okay, instead of smaller shaft, it will become bigger shaft. What will happen to the reliability is that is the that original bearing can support or not? This is called the reliability. This is what the question asks. What if the original design is this value, this dimension, and then you have to modify to become larger value for the shaft. Okay, so what happened? Okay, so for table 11.2, 0.2 millimeter bearings, C10 61.8 kilonewton, equivalent to 30,000 pound, using equation 11.12, recalling equation AF equals to 1.2, FD desired what 413. Okay, uh, X naught 0.2. Okay, it is better if you have the textbook with you, go back to the tab equation example 11.3, you will see what the question wants. Okay, and then you get this value. Okay, which is higher, expected much higher than 0.99. Okay, and then the two parameter Weibull distribution. This is the Weibull distribution. Remember what is the Weibull distribution? Okay, the Weibull distribution basically is the way that we predict the life and the force of a bearing, because bearing, many factors between this is bearing is different than you are analyzing shaft, beam, spring, and everything, because the bearing itself, first the bearing uh, is come from company, and then when you install the bearing is inside your casing. You have to open the casing, then you can get the see the bearing. Okay, then you will do the operation of bearing until the maintenance come, and you may change the bearing itself. Okay, but you don't know when the bearing will uh, will break down. Okay, like your car, when you go to do the service, the mechanic will say this car can run for 10,000 kilometer. After 10,000 kilometer, come back and go for maintenance service. Okay, why don't it extend to 2,000 20,000 kilometer? No, because the specification, the oil, the lubrication, the bearing, and everything is fitted to around 10,000 kilometer, and then you have to change. Okay, because you don't want to car to break down anytime. Okay, so see here, this is the example 11.10, life, everything. You trace back the value, trace back. Okay, try to trace back, and then you get the reliability RA RB, because you have two RA and RB. Remember, when you have two bearings, Okay, A and B, A and B reliability should be for both RA, RB, both must be counted for both. That is why the equation RA RB. Okay, because you have two bearing. If you have the three bearing, four bearing, it become RC and RD and so on. Okay. Um, when two bearings are made identical for simplicity, reducing the number of spares and attention and the loading is not the same. Both can be made smaller and made with reliability goal. If the loading is separate, more heavily loaded bearing can be chosen for reliability goal, just slightly larger than overall goal. So if the is identical, okay, uh, you can make it smaller. Okay, smaller. You can choose a smaller size of bearing. Okay, but if one is more load is given this one, and then this one, you should you should choose. This is more heavily load bearing. This is more lower load bearing. This is what Rebati says lah. Okay, so in cases for pure thrust bearing, pure thrust loading, what is a pure thrust loading? Okay, pure thrust loading is the most related example that I can think of is your car, your brake. Okay, your brake when you are you're pressing the brake. Okay, when you are driving a car, you press the brake. The brake will clamp to the tire. Okay, to the tire, to the cam, to the tire. Clamping, that clamping is thrust. That clamping is thrust. Okay, because if you can imagine the mechanism, you press the brake, it clamp. The brake pad it clamp. Okay, clamp the tire. So that clamp is the thrust force. The moment it hit the brake pad, hits the tire, it will have the clamp thrust force. Okay, that's example that I can give to you for the pure thrust loading. Okay, consider a constrained housing depicted in figure 1119 with two direct mount roller bearing resisting an external thrust 1000 Newton, shaft speed 1900 950 revolution per minute. Okay, can read. And then choose suitable tapered roller bearing for A, choose suitable tapered rolling bearing for B, find relativities RAB and R. Okay, so you can see here one have the more load, one have the lower load. What will happen? What what do you choose for the bearing? Okay, okay, by inspection note the left bearing carries the axial load as properly labeled as bearing A. Okay, left bearing is more greater than B. Okay, since bearing B is unload, we will start RB equals to 0. RA R equal to RA 0.95. No radial load, no industrial load. Applicable for uh, A is KA FAA. So we set KA equal to 1, find C naught in trust column. Avoid iteration, you get this. Okay, the multiplied life rating 6.33 from equation 11.10 for bearing A, C10 equal to this location and you get 16,000, and this present one possibility as 1 inch bore uh, cone size cup. Where do you get this? You get from figure 1115. Better that you have the textbook with you. You can refer what I mean by 1115. The spec is in the table. Okay, and then bearing B explain no load. Remember in this question said that there are two bearing, one have more load, one have lower load. Exactly, B has no load. Okay, and the cheapest bearing of this ball size will do include a ball and roller bearing. Assurability is that okay greater than 0.95 as one expect for bearing B. Desired and equivalent load is 0. So you put this, you get 1, and you get the derivative is 0.93, which is greater than the derivative equal 0.95. Okay, so method of fit. Okay, table 11.2, 11.8 shows the rating of a single row 0.2 bearing deep groove, which includes show the meter recommended for a shaft sheet. Okay, okay, you can read all this. Okay, in tapered roller bearing, bring the book with you. You can see where is level 11.5, level 15. The cup shoulder diameter should be equal or less than dB. What does it say here? Additionally, free hydropical flow is not to be impaired by obstructing a way of analysis. This hydropical flow, everything you will learn better in the next topic on general bearing, where I will explain a lot better. This ball bearing also have lubricant, but it's not explained in much more detail. Okay, and the oil passageway or about side of bearing need to be provided or oil rated some everything. Okay, you will learn better in the next chapter. You just you have to know that some bearing needs lubrication. Okay, so that's all for this video. We see you in the next video. We talk about lubrication for bearing. Okay, thank you very much.